Good morning. Thank you very much for your time today. I know how busy everyone is. My name is Al Aguirre, and I am the Midwest Regional Sales Manager responsible for sales of our temperature and power controls. Just as a point of order, I want to let you know that everyone is muted, and you will remain muted for the entirety of this presentation. I'm hoping you'll have questions, and I ask that you hold your questions till the end, and then use the chat feature for questioning. The presentation will be in two parts. The first part will talk about the basic functionality of this SSR, and then the second part of it will talk about the enhanced diagnostic features. So what is it? GRS-H and GRS is a solid state relay. It's available in two formats. As you can see here pictured at the top with heatsink and at the bottom without. It is a single phase relay, but it can be gained for 2 and 3 leg configurations. We have current sizes from 15 to 120 amps. It's available in 2 voltage ranges, 480 and 600. It is zero cross switching. It accepts 2 digital signals, either a 6 to 32 volt DC signal, so that's low voltage, or a 20 to 260 volt AC DC signal. There is no option for an analog signal, by the way. There are some diagnostic LEDs, IP20 protection, which means obviously it has to go in a panel, and there are some optional alarm outputs. One of the main goals of this redesign was to have a reduction in the size, and I think we've accomplished that. If you look at both of the first two SSRs, this one here and this one here, you'll see that they're only 17.5 millimeters wide, so it's about 3/4 of an inch. So the first size here, the first footprint, is covering both the 15 and the 25 amp sizes. They share the same physical dimensions. And then the next one over is for 30 millimeters. They all have the same width. Now, if you look at the drawing on the bottom, you'll see that the 30 amp, which is the second one here, is taller. So the heatsink is larger. Obviously, it has more heat to dissipate. But the width is what's important here. I don't think the depth is going to be an issue. Throughout the entire series here, we've kept a pretty small profile. The module itself, up until and through 75 amps, is the same width. Of course, the heat sinks are larger. When you get into the 90 and 120 amp size, the module is wider. But overall, I think we've done a very good job of slimming this down, and that is one of the key selling points of this product is going to be the slim size. So how did we accomplish it? Well, the main thing we did is we oriented the line and load connections so they were top to bottom. This is in contrast to the GTS. It's another one of our relays, DIN rail style, which had the control signals parallel to each other at the top and had the load and light connections, again, parallel to each other on the bottom. All right. The other thing I want to point out in this slide is the connections here for your control signals. These are done via a spring-loaded terminal. They're push-in terminals, so no tools required, and it is flush mounted. But more importantly, again, they're right within the same module, so we did not have to increase the width of the module itself. Even when you go to this one here, we'll talk about this more in the second part of the presentation. This is a 6-pin terminal here. And the additional pins are for when you get into some of the diagnostics and you need the outputs. But again, we were able to keep them in line vertically, which means that we did not have to increase the width. Some of our competitors also tout a very slim profile, but if they get some alarm outputs, and others do have them, they usually then no longer have such a slim product. So we were able to keep that slim product up to 30 amps, up to 30 amps with diagnostics, and only 17.5 millimeters wide. Keeping on discussion on the mechanics of it, it has a very robust spring-loaded mechanism here to attach to the DIN rail. Note this tab here, it's going to grab and it won't let go, so this will not be coming off. There's a connection here for your ground signal. Going to the right, this is the connection. It's a screw terminal, what they call a box clamp type screw terminal for your line and load connections. Again, very robust. Once these go in, they will not be coming out. And we keep saying that this is a DIN rail style product, and it is. But there are also mounting points here and at the bottom, so you could mount this directly to your panel. And then, of course, this mounting point here is the same one we talked about. It's for your ground connection. So again, DIN rail style, but it can be mounted directly to the back panel. Okay, let's talk a little bit about heat. By now, I'm sure everyone knows that temperature or heat is the Achilles heel for SSRs. They're not just ours, it's just inherent to the technology. So whether it's ours or anyone else's, it's something you need to be aware of. And I'm sure you're also aware of derating curves that are associated with temperature. Well, we have two derating curves. We'll look at those in a moment. One based on temperature, but the other one is based on the horizontal spacing. Hopefully, if we have more than one SSR in a panel, is something that we need to take account of. All right, so these are the derating curves, and we have one like this for every size out there. This example happens to show the derating curve for sizes 15 to 30 amps. The one on the left here is for the temperature, and the one on the right here is for the distance. First, let's look at the temperature one. Something I want you to be very, very aware of, so you don't get into this trap here. And someone may look at this very quickly and say, oh, you start to derate here, and that's around 25 degrees C, so that's where you start derating. That's not the case. If you notice, this bottom line, this dashed line, is for a 15 amp SSR. And so you have to look at 15 amps here, follow this across, and where we start derating it at 40 degrees C. So anything warmer than that, we start to derate. Cooler than that, you can actually switch a little bit more. I wouldn't recommend doing that. It just tells you that there's a safety margin here if you're a little bit cooler. This is the graph for mounting distance, and if you notice here, the 15 amp unit, which is this dashed line, pretty much from 20, which is the ideal mounting distance, 20 millimeters from SSR to SSR, going down to basically touching, it still is able to switch the full rated current, which is 15 amps. How can we do that, you might ask? Well, if you recall, we used the same heatsink for the 15 and the 25 amp SSR. So in actuality, the SSR when applied to the 15 amp unit, the heatsink when applied to the 15 amp unit is oversized. That's why we can dissipate all that heat generated. And then you can see here for the 25 and the 30, there are derating curves based on the installation distance. Now, I've been asked by some people that I've shown this to, which then becomes the governing chart. Should I be looking at the temperature of the panel? Should I be looking at distance? Well, of course, you have to look at both. And then how do you make that determination to find out the proper installation? And I would say if you have a doubt when you're actually looking at this down the road, hopefully, as you're talking to customers, give us a call. I don't want to go into the kind of detail now for this presentation to keep it at the 30 minutes, but give us a call. So as we've mentioned, temperature is a consideration, and it is the Achilles heel of SSRs, but wouldn't it be nice to actually be able to do something about it and not just say, okay, it's something we need to be aware of and not then do anything about it. So this is a feature I want to talk about now. It's an automatic power off based on an over temperature set point. Now this is a feature that actually was on our GTS SSRs, but really no one knew about it, or I think understood it very well. But it's a simple concept. And if the temperature increases beyond this threshold, we turn the power off and we turn this yellow LED on. The power off yellow LED on, of course now your heater is no longer getting hot or has heat. At some point it'll start to cool off again, and as soon as it goes beyond this point, we turn the power back on and the yellow LED is off. Now it's a neat feature. I think it's going to save you from blowing up your SSR. It is a standard feature on all GRS-H models, 50 amps and above, and then it's optional on all others. So, continuing the conversation about temperature, when you get into the two larger sizes, being the 90 and 120 amp SSRs, a fan is required to dissipate the heat. And what I want to talk about right now is just what is going to be required for you as far as a decision. So the fan's going to be there. The only thing you need to decide, or your customer needs to decide, is how am I going to power the fan? Am I going to power it with 230? Am I going to power it with 115 or 24 volts? Now, the part number itself, you can see here, the first two, fan 60, is the same part number for both the 90 and 120 amps. So it's one part number only, and that'll give you a 230 volt powered fan. The only reason we show you the two line items is to show you that there is a difference in the size of the fan dimensionally when you go from the 90 to 120 amp units. Same thing for the next two choices. Fan 61 is for a fan powered with 115 volts. And again, the only reason we're showing it here as two different line items is to show you that there is a size difference for those two fans, depending on the current. And then we have an option here for a 24 volt powered fan, and that's fan 62 as a part number. And that's only available, it's only one size for both of those units. And these options up here is highlighted in yellow. Once you power them on, they're on all the time, right? You put power to the fan and it's running. We have another option, which is a cooling fan with smart activation. And so using the same sensor that is monitoring the heat sink temperature that we use for the automatic power off in case you go over temperature, that same sensor is monitoring the temperature of the heat sink. And if it goes above a certain temperature, we actually turn the unit on, turn the fan on, and then turn it off once it reverts below that temperature. Now, obviously, that temperature is lower than the temperature at which we turn the power off, right? So what's the advantage? I was talking to somebody and they said, well, what's up with that? I mean, why would we offer that? Well, think about it. If you have one of these fans on an SSR, it's going to be the only moving part. It is a solid state relay after all, right? So by utilizing this smart activation, you're going to increase the lifespan of the fan. I don't think it's so much the savings in power. I think it would be minimal. It's really extending the life of the fan, I think, is the key benefit there to the customer. Okay, so in summary, GRS-H, it's a solid state relay, very slim, single phase, but you can get them together for 2 and 3 phase configurations. Current ranges from 15 to 120 amps, 480 and 600 volt ranges, 0 cross switching, 2 different types of control signal inputs, low voltage, and what I'll call universal or wide ranging voltage, AC/DC, the LEDs for diagnostics, the IP20, and the alarm outputs. Okay, so now let's talk about some of the enhanced diagnostic features. So as mentioned earlier, we have this feature where we can actually turn the power off if the SSR gets too hot, the heatsink in actuality. And it's available as a standard on units at 50 amps and above, optional all others. What I want to talk about now is actually getting an output associated with that. So, getting that power off is great, but I think it'd be even neater if we can actually give you an alarm output so that the machine knows that you potentially are making scrap here, right? So this is the similar chart as we saw earlier for just turning off the power when you get beyond a certain threshold on temperature. But at the same time, we have two alarm LEDs, the temperature alarm and the fault alarm. This is mislabeled here, but the real one will say fault alarm. Both those come out. More importantly, you're going to get a output that you can now bring into your machine and know right away, hey, something's going on. One thing I want to point out, obviously to do this, it requires a processor, and they're a small processor, but nonetheless, because it's looking at the temperature, and it's also looking at, it's also able to do some logic and give you an output. We're going to require power to the SSR module at all times for this to work. So in addition to the over temperature alarm option, we also have something else called the fault alarm diagnostic option. And I'm going to call it a poor man's heater burnout. Now I have to caution you and point out that this is not a traditional heater burnout. It doesn't have a CT, and we will not be able to read the full range of the current. But what it can do is it can detect if you have a loss of your line voltage here, or if you are stop conducting current to your load here. So in any of those cases, we'll be able to detect that and give you an alarm output. Now I said it's not a true heater burnout, and I made it sound like that is a con, right? But I think it can be a pro in that you don't require a CT, so you don't have that cost for the CT. You don't have to wire the CT in, and you don't have to worry about that output into your logic and monitoring the current at all times. So I think it's actually the best of both worlds. We're able to detect this loss of the line voltage or the current going to the heater, and of course at that point you're not getting heat, and we'll notify you right away. So this chart shows you what's going on here with this situation, right? So let me go through it real quickly. As I mentioned, because this unit has a small processor, you need 24 volts for it to work. And in this first scenario here, what you've got is your control signal is on, your load current is on, and at this point here, by this blue line, you lose your load, right? There's a load failure of some sort. Immediately your LED comes on and your alarm contacts change state here, okay? Now I want to caution you, it shows here normally open and normally closed contacts. You don't get both in the relay, you get one or the other, but we wanted to show you what happens in either of those scenarios. But as soon as your load is restored here, then your alarms are turned off. Both the alarm outputs and the LED. And of course, the alarms get restored or get reset when you reset your load. In this scenario here on the right side, what is happening? Okay, you've got a control. You got a power coming to the SSR, 24 volts, and you've got a control signal, and all of a sudden you have a load failure. Same thing has happened in the other example. Your LED comes on here and your alarm changes state at this point, right? But what's happening? Well, you could have a case where, right, you've got an alarm output, you've determined that maybe you've got a bad heater, it's going to take you some time to change the heater out, but you want to acknowledge the alarm or turn the alarm off. Maybe it's a buzzer or something. And so the only way to reset a latched alarm, if you have not fixed the load failure here, is to reset the power, recycle power to the unit. So recycle power off here and all your alarms go off. All right, this chart here, this slide here shows what's going to happen with your three LEDs and how they operate in different scenarios. So let's take them one at a time. So the first scenario at the top is your SCR is off. You have no alarm conditions. And of course, all three LEDs. You've got a green LED, a yellow temperature LED, and a red fault alarm LED. All of them are going to be off. That's obvious. Second line, second scenario, your SCR is on. It's working, you have no alarms, your green LED is going to be off, and going to be on, and the other two will be off. Third scenario, your SCR is on, you have a fault alarm active. So the fault alarm basically is the one where you've lost your load connection. So your green LED is on because it's trying to work, but you've lost the load. Your yellow LED is off, but your fault alarm LED is on. And if you've got the alarm output option, of course, that output is also on. Next scenario, SCR is on. Your over temperature alarm is active. Now, as soon as you get into the over temperature situation, we turn power off. So the LED, the green LED is off. The yellow one is on because you're in over temperature, and your red fault alarm is off. I think that's pretty obvious. The next scenario, SCR is on. Both the over temperature and the fault alarm are off. Of course, the yellow LED and the red LED are on. The green one is off because when you go into an over temperature situation, we turn the power off. And then the last one, basically the SCR is off. You have a fault alarm that is active and it's latched, so there's no green or yellow LED, but your fault LED is going to be on. And the difference between these two scenarios here, this one here, is that the SCR is off. It's not getting a control signal. All right, so let's talk a little bit more about the alarms. I already mentioned there's a couple of different alarms. How do you know which one you select? Well, what I've done here is basically shown you the number code, ordering code, and how to go ahead and select the alarm type that you want. So the first thing you'll notice as I zoomed in here on the input type, there are two input types. The low voltage DC, which is represented by a letter D in the ordering code, and the 20 to 260 volt AC DC, which is represented by an A. And if you see here at the alarm output options, the first three have a little footnote, number 1, and number 1 on the data sheet says not available for the type A inputs. I wish they would have said, hey, these are available for the DC, but anyways, that's what they put on here. So if you've got a DC signal, typically, and you want both alarms, you're going to stick with these three. One of the differences, option number 1 and 2 are for dry contacts. Now they use the terminology here in the data sheet, insulated contacts, but more commonly in the US we call these a dry contact. And then the only difference is option number 1 is for normally open dry contact, option number 2 is for normally closed. Option number 3 is for a PNP output, normally open. There is no normally closed version of that. And then output 5. Output 5 is, you have to think about it, it can be used on a type A version control input. So if you've got the 20 to 260 volt AC DC and you want some alarms, that's the one you have to use. And you will only get the thermal alarm. There is no loss of load alarm output if you have the A-type control signal. You can also use it though for the DC if all you want is a thermal alarm contact output and you're not really concerned about the loss of load. Again, it's a dry contact for that output and it's normally closed, so that's the only option there. All right, so this is the entire ordering code. It's very simple. Obviously at the very beginning you have to put in your series type, either GRS or GRS-H, and then going in order. The first box is for your current, second box is for your voltage, third box is for your control signal. If you go into 90, 120 amps, I'm sorry, I skipped one. Next box is for the optional alarm outputs here. Following that, if you go into 90 and 120 amps, you will be required to have a fan. You're just going to decide which fan power do you want, and the next two fields are unchangeable. And when it talks about new here, this is only in reference to our previous model, the GTS. 30 amps is a new range. We did not have 30 amps in the GTS, and this over temperature alarm for the AC input was is also a new feature, as is the fan with smart activation. So I think the ordering code is fairly straightforward. I want to talk a little bit now about the commercial landscape. You know, as we were looking at this product, we were aware of that there are certain well-known benchmarks out there, companies such as Carlo Gavazzi and Crydim, to mention a couple. And we want to make sure that as far as technology and price, we were on par or better than our strongest competitors. And I think we've really hit the mark here. On technology, I would stack our product against anyone when it comes to a SSR of this type, zero cross. And on pricing, I think we've also hit the mark. We know that the GTS, when it came into, when we had to compete in large, especially OEM opportunities where it was very cost conscious, we had a hard time competing. It was just due to a number of factors that gave us a certain cost structure that made it hard for us to compete. And we've really sharpened our pencils and did a lot of work to come up with a good product that is also going to be less expensive. And so I've got a couple of examples here just to give you a for instance. So the first example is for a SSR at 25 amps, 480 volts with a DC input. And you can see the difference here. For the GTS, the list price was $71, or is $71. For a comparable GRS-H, it's only $59. That's amazing. For the 40 amp, again, similar specs, 40 amps, 480 volts with the DC input, 102 versus 84. And so that is significant. Now, that's about a 13-14% differential. I can tell you that you're not going to see that same differential throughout the full range. I know that once we get into larger amperages, I think beyond 75 amps, they'll still be less expensive. The GRS-H will be less expensive, but you may not see that large differential. A number of things that we did to really come up with a better cost structure. One of them is we no longer offer a 240 volt range product. The GTS had 3 voltage ranges, 240, 480, and then 600. But looking back historically, we didn't sell as many of the 240. And then also, obviously, if you have a unit that can handle up to 480 volts, the 240 will be included in that. And so, you know, by eliminating one whole voltage range, you know, really is a cost savings for us. We don't have to produce them, nor do we need to manage the SKUs or the inventory. Another thing we did is we're able to now, with some of the new technology, some of the new series of power controls, have shared components in between different products, which allows us to buy smarter and larger quantities and really pass that savings on to the customer. And I think the third contributing factor was automation, you know, for this line. So those three things, I think, combined, and other things, really give us a much better cost structure. I have to say that we are really encouraging our partners to stock these, especially for the replacement or MRO market. As I'm sure you know, these types of opportunities are going to be who has stock right now, who can get me up and running right away. And if you're going to do that, which we do encourage you to do, keep in mind that just based on our historical knowledge, and also just due to industry data that we've gotten, the more popular sizes are between 20 and 50 amps. So keep that in mind. On a day-to-day basis, what you're going to sell most of is 20 to 50 amps. I'll tell you that when I saw this product coming down the pipeline, I was very excited. I knew that we had lost some opportunities in the last year or so. And so what I did is I went back and started looking through opportunities we had lost in that time frame, and started contacting some customers and distributors. And some of those are coming back around, and I think we'll have a good shot at them. So I would just ask you, think of your customer base. Applications are endless anywhere where you're selling a temperature control, whether it's in the plastics field, whether it's into ovens, whether it's in packaging. They're out there bringing some opportunities. As far as sales tools, there's quite a few. If you look at the data sheet, if you look at the product page for all of our products, you will see at the bottom something that looks like this part of the website, and it basically is the area of our website where you can start downloading information for each product. So for the GRS-H, we have 2 and 3D files available. There is a brochure, a flyer, data sheet, manual, and certifications. Now, what I think makes sense to use initially will be this 2-page flyer, which I've shown here. The flyer itself, I will grant, does not have all the technical specifications of the data sheet, but I think for an initial presentation, it has enough. Obviously, the first page has a nice color picture of the unit. You can talk about the slim size, talk about the top to bottom configuration for the wiring, for the load and the line. On the other side, it shows the various product ranges. It shows some information here about dimensions. And then there's a number of symbols here, which I've zoomed in on here, which then allow you to talk about things like, hey, it's a digital input versus analog, zero cross, thermal alarm, so on and so forth. So I think it's a good piece. It doesn't weigh much. Obviously, you can put these in your briefcase. Gets the ball rolling. Now, if the guy's interested, you either can print out the data sheets or email them to him and continue with the conversation. So the other thing I want to let you know of is this down here. All of our partners by now should be aware that we have a new online configurator, which also gives you dynamic stock availability. You know, in the past, we had a configurator, but for stock, we relied on a daily printout, which by the end of the day was no longer accurate. So with this new configurator, everything is live, pricing is there, and then stock check is going to be dynamic. It's going to be, you know, moment by moment. Not all the part numbers are loaded, so I'll also be sending the Excel spreadsheet for this product, where you can look at the product and start building it based on current and other options. But a lot of them are, primarily I think the ones that are loaded on there now are for the GRS-H, or the one with the heat sink, which we think is going to be more popular anyways. So what is our value proposition? What do we bring to the table, right? What do you want to lead to with your customer? I think for the OEM, we want to talk about increased production. You know, we're going to be able to react and notify them of failures or issues with the product. So, you know, allow them to quickly react to that and hopefully save scrap. Machine uptime, it's a very robust unit. It has, all of these have an internal MOV, so very high immunity to transient voltage spikes. Very easy to install, either DIN rail or to the back panel, because of the spring-loaded clips, spring-loaded pins or terminals for the control signals. Easy to install, simple to troubleshoot via the LEDs. And I think the other thing we got to keep playing up is the panel space savings, right? And price. All of that, I think, is a good combination and a winning combination for the customer and for you. Stay tuned. In the next couple of weeks, hopefully no more than about 3, we'll be having a similar presentation on the updated GQ, which is our hockey puck style relay. In the case of the GQ, it's more of a redesign versus a complete clean sheet project. So we will be keeping the GQ series name, but there will be some product enhancements and better pricing coming soon. So with that, I say thank you, and I'll open it up to questions. I understand maybe you want to digest this a little bit. If you have questions later on, feel free to contact me. There's my email address and my phone number. I will be getting out the presentation to you in the next couple of days in a PDF format. I will be getting out the price sheet to all of our distributors, and in the not too distant future, we'll be posting this presentation online. So if anyone in your team was unable to see it today, they'll be able to view it at their convenience. Well, with that, I want to thank you and see you next time. And give me a call if I can help you. Thank you very much.